Welcome to this explainer. Today, we're going to embark on a really fascinating journey. We are going to construct a complete mental model of a digital trade ecosystem quite literally from the ground up. It's easy to think of e-commerce as just clicking a buy button on a website, but it's actually this massive, invisible architectural marvel. It's a hugely complex grid of infrastructure, security protocols, payment gateways, and legal frameworks, all operating flawlessly in the background. To build this ecosystem, we're pulling directly from a super solid academic blueprint. This material comes straight from the MCO 303 e-commerce course. That's a comprehensive third-year Master of Computer Applications curriculum developed by the experts over at Vardhman Mahavir Open University in Kota. It is incredibly thorough, spanning 13 distinct units of study, and we're going to distill its core architecture for you right now. Okay, let's dive into this by defining exactly what it is we're building. E-commerce is basically the catch-all term for any commercial transaction conducted electronically on the internet. But think about how it fundamentally changes the nature of trade. Consider the huge difference between buying a physical product, which involves complex logistics, warehousing, and shipping, versus buying a digital good, like streaming a video or downloading software. With digital goods, the delivery and the transaction happen instantaneously over the exact same network. It's a total game changer. And the authors of this curriculum actually stated their goal right up front. They said the concise and sequential nature of the book makes it easier to learn. Well, we are taking that exact philosophy to heart today. This explainer is designed to be an incredibly efficient, highly focused learning tool. So we've mapped this whole thing out sequentially into 5 core pillars. Here's our roadmap for today. Number 1, foundations of e-commerce. Number 2, network and mobile tech. Number 3, security, threats, and risks. Number 4, transactions and payments. And finally, number 5, legal framework in India. Let's kick things off with Section 1, Foundations of E-commerce. Think about a traditional brick-and-mortar store for a second. They face strict, non-technical limits, things like physical geography and set opening hours. Plus, they deal with technical limits like localized, totally disconnected inventory systems. The broad architectural framework of e-commerce basically shatters all those limitations. It replaces the old way with a decentralized system, allowing enterprise data to flow globally in real time. It completely decouples the transaction from a physical location. And this expansive architecture, it enables a massive interconnected matrix of business models, which this brilliantly illustrates. Take the straightforward mechanics of consumer to consumer, or C2C, like an online auction site where you and I can trade directly. Now contrast that with the heavy, highly regulated infrastructure required for government to business, or G2B, where massive public sector procurement contracts are executed entirely digitally. We've even got intra- and inter-organizational frameworks operating completely behind the scenes. It's a huge web. Moving right along to Section 2, network and mobile tech. So, how do all those models actually function on a global scale? They run on what's called the information highway, or the I-way. This is a physical and logical infrastructure driven by immense global market forces. It doesn't just happen. It requires massive strategic alliances. Tech companies and telecom providers literally have to physically route data across borders. They rely on specific access equipment, think global router networks, fiber optics, and broadband telecommunications, to form the actual backbone of all this digital trade. But what's really interesting about this is how quickly that highway untethered itself. The historical shift from standard desktop e-commerce to mobile commerce relied heavily on WAP, that's Wireless Application Protocol. This architecture acts like a vital translator. It optimizes heavy web data so it can flow efficiently over limited mobile bandwidths. It completely transformed global transaction accessibility, allowing secure digital trade from simple mobile devices literally anywhere on the planet. Which brings us to Section 3, security, threats, and risks. Now that we've built this amazing digital highway, how do we stop the highway robbers? Because there are plenty of malicious codes, worms, and Trojan horses out there actively trying to hijack client-server connections. To fight this, administrators deploy layered defensive tools. You've got firewalls blocking unauthorized access right at the perimeter of the network. Meanwhile, the foundational science of cryptography steps in to scramble the actual transaction data itself. That renders it completely useless to an attacker, even if a worm somehow manages to intercept it. Within this defensive environment, there's actually a bit of a philosophical debate. You have security through obscurity, or STO, which basically attempts to hide system flaws and implementation details, just hoping attackers won't find them. It's kind of like hiding your house key under the doormat. Modern architecture, however, demands trust-based security. This approach just assumes the attacker already knows how the system works, but it relies on unbreakable cryptographic keys, biometric systems, and verified digital identities to keep the data locked down tight.
Next up is Section 4, Transactions and Payments.
Let's move to and see how this builds. With our perimeter secured, we can safely manage the actual money. This requires a really robust risk management approach to execute online transaction processing from start to finish. A great example is the Visa chargeback lifecycle. This is a vital safety net where disputed funds can actually be reversed from the merchant back to the consumer. It's brilliant because it forces businesses to maintain exceptionally high security and customer service standards just to avoid those financial penalties. And of course, e-commerce relies on a really diverse array of electronic payment systems to actually move that money around. Unlike a traditional credit card, which constantly exposes your static account number every time you use it, emerging digital token-based systems and smart wallets are much smarter. They generate unique, single-use codes for every transaction. This drastically reduces fraud exposure during transit, ensuring that even if a token is intercepted, it's completely useless for future purchases.
Now, for massive B2B supply chains, systems use something called electronic data interchange, or EDI. Instead of humans sending manual purchase orders back and forth, corporate servers literally communicate directly with each other in a standardized language. This drastically shortens ordering times and totally automates inventory. But, as you might guess, these massive efficiency gains require immense technical integration and incredibly strict legal contracts between the organizations to ensure everyone stays compliant.
And that perfectly tees up our final segment, Section 5, Legal Framework in India. Corporations have to secure all this internal data, and they do that using intranets for secure employee communication and extranets to grant limited, highly monitored access to external partners. Now, in India, this entire architecture is governed by specific IT acts, which define very strict compliance rules for digital trade. We're talking about regulations for data localization, establishing the legal validity of digital signatures, and outlining incredibly strict penalties for cybercrimes. So the crucial point is that e-commerce isn't just one single technology. It's a really delicate balance of business models, network infrastructure, rigorous security, payment processing, and legal compliance. By breaking down this MCA 303 curriculum today, we've basically mapped out the entire digital trade ecosystem. But I want to leave you with a thought to spark your curiosity. Looking at these 5 pillars today, with technologies like AI and quantum computing rapidly evolving right before our eyes, which pillar of this architecture do you think is the most vulnerable right now? Thank you for joining me on this explainer, and keep exploring.